So in the part 3 we completed up to this numerical. Next we'll continue. So in the question they are asking, show how would you connect 3 resistors. Already we solved a question based upon this, but in the previous sum they gave 3 resistors of different values, but here all the 3 resistors are having the same magnitude. Already I said, if you are getting any question based upon this one, means either the given circuit should be fully in a form of series, or it need to be in a form of parallel, or it need to be in a form of a combination of series and parallel, 2 series along with 1 parallel, or 2 parallel along with 1 series. So remember this condition. So now we will try along with this fourth condition. So what is the fourth condition is then? 2 resistors are in parallel along with 1 resistor in series. Now R1, R2, R3. What is the value of R1? 6 ohm, R2 6 ohm, and R3 also is going to be 6 ohm. First we need to complete the network which is in a form of parallel combination. So what is meant by parallel combination formula? 1 by Rp is equal to 1 by R2 plus 1 by R3. 1 by Rp is equal to 1 by, what is the value of R1? 6, R3 6. So 1 by Rp is equal to, do the cross multiplication, 6 plus 6 by 36. So 1 by Rp is equal to 12 by 36. So therefore Rp is equal to 36 by 12. It's going to be 1 12s are 3 12s are. Or you can just write it as common denominator 6, add the numerator alone, 1 plus 1 is going to be 2. So this is 1 by Rp. 1 by Rp is equal to 2 by 6 means, so therefore Rp is equal to 6 by 2. Rp is equal to 3 ohm, which is convenient for you. You can go along with that. So Rp is equal to 3 ohm. Now these 2 resistors has got combined and we got a single resistor like this, and that value is going to be 3 ohm. Along with that, 1 resistor is in a form of series. Now look at the final circuit, what type of combination it is. It's in a form of a series combination. So what is the formula? R is equal to R1 plus Rp. R is equal to, what is the value of R1? 6 plus 3. So R is equal to 6 plus 3 is going to be 9 ohm. So that means we got the answer for the first one. For the second one, we are going with this type of combination. That means 2 resistors are in series, along with that 1 resistor is in a form of a parallel, 6 ohm, 6 ohm, 6 ohm. So first what we need to do means, we need to find the net resistance for the 2 resistors which are connected in parallel. So series. What is series formula? R is equal to R1 plus R2. What is the value of R1? 6. R2 6. 6 plus 6, it is going to be 12 ohm. Now these 2 resistors has got combined and we got a single resistor as 12 ohm. Let's take over here. This is Rs. R is equal to 12 ohm, and along with that 1 resistor is in a parallel, and that is R3 is equal to 6 ohm. Now this circuit has got simplified like this. Look at the final circuit. It's in a form of a parallel combination. What is parallel combination formula? 1 by Rp is equal to 1 by Rs plus 1 by R3. 1 by Rp is equal to 1 by, what is the value of Rs? 12 plus 1 by 6. So now do the cross multiplication. 1 by Rp is equal to 6 into 1. plus 12 into 1 by multiply 12 into 6. 12 6 are 72. So now 1 by Rp is equal to 6 plus 12 is going to be 18 by 72. So therefore Rp is equal to 72 by 18. So if I am simplifying these two numbers, 118s are 418s are. So the net resistance is going to be 4 ohm. So what's the value of net resistance over here? 4 ohm. Second question also we got. Next, third one. So we'll come to this question at last after completing the concept called as power. Next, read the next question. An hot plate of an electric oven is connected to a 220 volt line. That means what is the value of potential difference? V is equal to 220 volt. Has two resistance coil, one is RA and another one is RB. Two coils are there, one is RA and another one is RB, and the resistance of each coil is going to be 24 ohm. Clear? Which may be used separately. In the first case, what they are saying means these two resistors can be used in a form of a separately, or it can be used in a form of a series, or it can be used in a form of a parallel. Clear? The two coils can be joined in a form of three different manners. One, it can be used separately, one it can be used in a form of series, and one it can be used in a form of a parallel. So if it is the condition, they are asking what is the current in the coils they are asking. That means I value we are going to find. So now we'll calculate the current if the two coils are used separately. So what is the formula to calculate current? I is equal to V by R. Therefore I is equal to, what is the value of V? 220 by, what is the value of R? 24. So if you are dividing these two numbers, 220 divided by 24, it's going to be I is equal to 9.166 ampere, or we can write it as I is equal to 9.17 ampere. Second condition, if the two coils are kept in a form of a series. Series means the two coils are connected in a form of end to end. First let us calculate the net resistance in series. R is equal to R1 plus R2. What is the value of R1? 24. What is the value of R2? 24. 24 plus 24 is going to be 48 ohm. So now find the current. I is equal to V by R. V value it is 220 and R value is 48. So 220 divided by 48, that will be equal to 4.583 ampere, or 4.58 ampere. Third, when the two coils are connected in a form of parallel. First we will calculate the net resistance in parallel combination. What is the formula? 1 by Rp is equal to 1 by R1 plus 1 by R2. What is the value of R1? 24 plus 1 by 24. That gives a common denominator 24. Add the numerator alone 2. So the 1 by Rp it is 2 by 24. Therefore Rp is equal to 24 by 2. 24 by 2 it is going to be 12 ohm. 25 by 2 is going to be 12 ohm. So therefore I is equal to V by R. V value is 220 and R value is 12. So 220 divided by 12 is going to be 18.33 ampere, or 333 is in, or you can write it as 18.33 ampere. So remember one condition alone here. Look at this. Two resistors are there. Both the resistors are having the same magnitude. What is the magnitude of each resistor is going to be 6 ohm. So look at the magnitude of that means the net resistance, we got 3 ohm. Now go to the sum we solved right now. Two resistors are there, both are connected in a form of parallel, and these two resistors are going to have the same magnitude. The net resistance we got as 12 ohm. That means when two resistors are there, when two resistors are there and these two resistors are connected in a form of parallel which has same magnitude, the net resistance will be half of that. The net resistance will be half of that. So in the previous sum, if you are seeing means what two resistors are there, both are having the same magnitude, the net resistance will be, what will be the half of 6? Half of 6 is going to be 3 ohm. So if it is asked in a 1 mark means you need to solve it directly like this. So here what are two resistors are there? 24. Both are having the same magnitude and it's connected in a form of parallel means what will be the half of 24? Half of 24 is going to be 12 ohm. Yeah, so remember that condition carefully. Next, so in the figure 11.12, so in the figure 11.12, R1 is equal to 10 ohm, R2 is equal to 40 ohm, and R3 is equal to 30 ohm, and R4 is equal to 20 ohm, and R5 is equal to 60 ohm. So how the combination is given means it's like this. So till now we solve the numericals based upon only in series or only in parallel. Now we come to the next combination, either it's in the form of a combination of series and parallel. This is R1, R2, R3, R4, R5. What is the value of R1? R1 is 10 ohm, R2 is 40 ohm, R3 is 30 ohm, R4 is 20 ohm, and R5 is 60 ohm. And the potential difference is going to be 12 volt. Plus minus, current is flowing from higher potential towards the lower potential. And here they connected an ammeter. So a plus minus. Now, so if you are seeing in that circuit, there are two different networks are there. So what is the first network? R1 and R2 is connected in one network. Like then R3, R4, R5 are connected in another network. So how we need to simplify means we need to simplify the network wise. First we will simplify the network 1. So look at the network 1. What are two resistors are there in network 1? R1 and R2. That two resistors are connected in a form of common point. Common point means it's going to be parallel. What is parallel formula? 1 by Rp. Since it is the first network, we can write it as Rp1 is equal to 1 by R2 plus 1 by R3. 1 by Rp is equal to, what is the value of R1? 10 plus Rp, sir, R2 40. So do the cross multiplication. 40 plus 10 by 400. 40 plus 10, 50 by 400. This is 1 by Rp, but what we need? Rp we need, right? So therefore Rp1 is equal to 400 by 50. 0, 0. 1 5s are 8 5s are. So the net resistance of the network 1 is going to be 8 ohm. Clear? These two resistors has got simplified and we got a single resistor like this. Let's take it as Rp1. And what is the value of Rp1? We calculated 8 ohm. Now come to the second network. So look at all the three resistors R3, R4 and R5. What type of combination it is? It's in a form of a parallel again. So I can write the parallel formula. What is the parallel formula? 1 by Rp2 is equal to, since it is a network 2, we are using it as Rp2. 1 by R3 plus 1 by R4 plus 1 by R5. So 1 by Rp2 is equal to 1 by, what is the value of R3? 30 plus R4 20 plus 1 by 60. Make into the common denominator. Then I can multiply this number by using 2, and here also 2. Here 3, here also 3, and here 1, numerator also 1. If you did the multiplication like this means, how it will rearrange? 1 by Rp2 is equal to 1 into 2, 2 by 30 into 2, 60 plus 3 by 60 plus 1 by 60. So that gives in 60 is going to be the LCM. Add all the numerators. 2 plus 3 plus 1 is going to be 6. This is 1 by Rp2. But what we need? Rp2 we need. Rp2 is equal to 60 by 6. 1 6 are 10 6 are. So these three resistors has got combined, and we got a single resistor as Rp2 is going to be 10 ohm. Now this end, I mean this end is connected over here, and these two ends are connected to the battery. Now this overall circuit has simplified like this. Clear? Has simplified in this. So now look at the final combination. Is it series or parallel? It's in a form of a series. Reason, the end of Rp1 is connected to the end of Rp2. So what is the formula? Rs equal to Rp1 plus Rp2. Rs equal to Rp1 plus Rp2. Rs equal to, what is the value of Rp1 we calculated? 8, and Rp2 is going to be 10. Then what will be the overall net resistance over here? Rs is equal to 18 ohm. What is the total resistance of the circuit is given over here? Rs is equal to 18 ohm. Next we need to calculate the total current. So what is the formula to calculate current? I is equal to V by R. So I is equal to, what is the value of V? It is given in the question, 12 by, what is the value of R we calculated? 18. Now simplify these two numbers by using the 6 table itself. 2 6 are 12, 3 6 are 18. If you are again simplifying the two numbers, we can get it as I is equal to 0.666 ampere. R we can write it as I is equal to 0.67 ampere. Next, a piece of wire resistance R. So initially a wire is there. Let's take the name of the wire as R, and this wire is having a resistance of R. Clear? So a piece of wire is there, and what is the name of the wire I gave over here? R itself. Clear? And what is the resistance of the wire? Its resistance is going to be R. And this wire is cutted into how many parts? 5 equal parts. Then what will be the resistance of each part? R1 is equal to R by 5. R2 is equal to R by 5. R3 is equal to R by 5. R4 is equal to R by 5. And R5 is equal to R by 5. Clear? So after cutting, what will be the resistance of each part over there? Each part is going to have a resistance of R by 5. Suppose we are cutting into 4 equal parts, then I can write it as R1 is equal to R by 4, R2 is equal to R by 4, R3 is equal to R by 4, and R4 is equal to R by 4. The same as it is 3 parts, you can write it as R by 3, R by 3, R by 3. So read the question carefully, whether they are saying it as 5 parts or 4 parts or 2 parts, whatever it is. First we need to know what is the overall resistance. In that, how much part they are going to cut. If it is 5 part means overall resistance by 5. 3 part means R by 3. 4 part means R by 4. 2 part means R by Clear? Remember this condition carefully. Now, so and after cutting, these parts are then connected in a form of parallel. So and after cutting, how they are connecting over here in a form of parallel. What is parallel formula? 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus 1 by R5. So now 1 by Rp is equal to 1 by, what is the value of R1? R by 5 plus 1 by 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 R by 5. Clear? So this one, it's in a form of a complex fraction. If you are going to rearrange it into a normal fraction, means how we can write this one means 5 by R. So it will rearrange into 5 by R plus 5 by R plus 5 by R plus 5 by R plus 5 by R. So now 1 by Rp is equal to, common denominator is going to be R, add all the numerators, it's going to be 25. But what we need? Rp we need. So Rp is equal to R by 25. Take the reciprocal over here. But in the question what they are saying is then, if the equivalent resistance of this combination, that means a parallel combination is R dash they are saying. That means instead of Rp, we need to substitute as R dash is equal to R by 25. Now in the final what they are asking, then the ratio of R is to R dash. What is the value of R? R value is going to be R. Is to, what is the value of R dash we calculated? R by 25. A is to B, we will be writing it as A by B. Then how I can write this one? That will be equal to R by 25. Then how I can rearrange? R by 1 into 25 by R. So the R you can cancel each other. Remaining what will be then? 25 by 1 will be there. So how we can write this one? R is to R dash will be equal to 25 is to 1. Simply you can write it as 25. Next. So the next topic what you are having is heating effect of electric current. So in lower class we learned about the two effects are there. In that one of the effect we are going to learn right now. That effect will be calling it as the heating effect of electric current. So what does mean by heating effect of electric current? So whenever current is passes through any type of a conducting material, let's take it as an iron box or geyser or a bulb, whatever it is. So what will happen? This conducting material, due to the hindrance in it, hindrance is nothing but called as the resistance. Hindrance is nothing but called as the resistance. Due to this resistance, what will happen? This conductor will start to produce the heat in it. It starts to produce the heat in it, and that effect only will be calling it as heating effect of electric current. So what is meant by heating effect of electric current? When current passes through the conducting material, the conducting material produces the heat. Due to what it is going to produce the heat means due to the hindrance. Hindrance is nothing but called as the resistance. So and this effect only will be calling it as the heating effect of electric current. Next, based upon this observation, Joule he gave a derivation for this, and he gave a relation is H is equal to I square R T. So what is the relation he gave? H is equal to I square R T. So what is the relation? H is equal to I square R T. How we obtain this one? So from electric potential or from the potential difference formula. What is the electric potential formula? V is equal to W by Q, or we can rearrange it as W is equal to V into Q. Let's take this is equation number 1. Next, from Ohm's law, So what is Ohm's law formula? V is equal to I into R. Let's take this as equation number 2. Next, from the relation current, charge and time, we can write it as I is equal to Q by T. Therefore, Q is equal to I into T. Let's take this as equation number 3. So now what you are going to do? We are going to substitute equation 2 and equation number 3 in 1. So what we are going to do? We are going to substitute equation number 2 and equation number 3 in 1. What is equation number 2? V is equal to I into R. What is equation number 3? Q is equal to I into T. These two equations where you are going to substitute means in equation number 1. What is equation number 1? W is equal to, instead of V, we are going to substitute as IR into, instead of Q, we are going to write it as IT. So W is equal to I into I square. So I into I is going to be I square R T. In the lower class we learned energy is defined as ability or capacity to do work. So instead of work we can rearrange it as energy. So the energy is equal to I square R into T. So what type of energy it is? Heat energy. So you can just write it as H is equal to I square R T. So what is the final formula we are having? H is equal to I square R T. So this formula, based upon the given data, we can rearrange in different formats. How we are going to rearrange means, what is the final formula we obtained? H is equal to I square R T. So this I am going to split into two parts. How I am going to split? I into R into T. Now I into R is nothing but called as V. Relation is the. Then I can write this one as H is equal to I V T. For a convenient, you are going to rearrange in a format of V I T. Clear? The first relation. So what is the first formula is then H is equal to V I T. Even we can rearrange this formula in a different manner also. So the I into T is there. So look at over there. I into T is nothing but called as Q. So instead of I into T, we can rearrange it as H is equal to V Q. This is the next relation we are having. Based upon the given data, we can use this formula also. And then, if I am going to rearrange in a different order. So what is the final formula I obtained? H is equal to I square R T. H is equal to I square R T. V equal to I into R means, therefore I is equal to V by R. So instead of I, we are going to substitute this value. Clear? Over here, right? Now, H is equal to V by R the whole square into R into T. Now, V square by R square into R into T. So here we can cancel R and then square alone. If I am cancel the two elements, remaining what will be then? H is equal to V square by R into T. So this is the third formula we are going to use. So if they are asking derive an expression for Joule's heating effect of electric current means, up to this we need to derive, and these formulas you need to remember carefully. So while solving the numericals, we will be using that formula. So what are the formulas are there to calculate the heat energy? H is equal to I square R into T. Another one formula is H is equal to VIT. Another one formula H is equal to V into Q. Next H is equal to V square by R into T. So what are the formulas? H is equal to I square RT. H is equal to VIT. H is equal to V into Q. H is equal to V square by R into T. Now, so based upon this, he gave a law, and that law will be calling it as the Joule's law of heating effect of electric current. So from this equation itself, we can expand that law fully. We all know H stands for heat energy, I stands for current, R stands for resistance, and T stands for time. So how it is there means heat produced in the conductor is directly proportional to the square of current. Heat is directly proportional to the square of current. Like that, heat is directly proportional to the resistance. Heat is directly proportional to the time taken through which the current passes through the conducting material. Clear? So what is the law over here? Heat produced in the conductor is directly proportional to the square of current. Heat produced in the conductor is directly proportional to the resistance. Heat produced in the conductor is directly proportional to the time through which the current passes. Clear? In all the three cases, it's directly proportional to each other. Next, applications of heating effect of electric current. Application in the sense in our day-to-day life where you are going to use this effect. In what are the places you are using this one? Electric laundry iron, electric toaster, electric oven, electric kettle, and electric heater. Apart from this, there are two more appliances are there. One is called as a fuse, and another one is the electric bulb. So these are the two important applications we will be learning in this chapter. So the first one is what you are having it as bulb. Generally, when a bulb will glow, whenever electric current is passes towards it. Which part of the bulb is going to glow over here? The thin filament only is glows, and the thin filament is made up of tungsten, and the tungsten is going to have a high melting point. One of the important 2-mark question: why the filament of the bulb or why the incandescent bulb is made up of tungsten, exclusively made up of tungsten means reason tungsten is going to have high melting point, and the melting point of tungsten is 3380 degree Celsius. And this filament is thermally isolated. Isolated means it's going to kept separately by an insulating support. And then the bulbs are filled with the inactive, chemically inactive gases. What are two gases that is going to be filled means one is nitrogen and another one is argon gases. For what purpose these gases are filled means in order to prolong, that means in order to increase the lifetime of the filament. They will be giving one of the gases and the other gases they will be asking in the form of options. What are the gases are filled inside the bulb? Nitrogen and dash. Like this they will be asking the question. So what are two gases are filled over here? One is nitrogen and another one is argon. For what purpose it has been filled means in order to prolong, that means in order to increase the lifetime of the filament. And then, so the next important application what I am having it is fuse. So what is meant by fuse and how it's going to work, and based upon what effect it is working means fuse is working based upon the heating effect of electric current. Based upon what effect the fuse is working? Based upon the heating effect of electric current. And what is the function of the fuse means it helps to protect. Protect means it's going to save. Which one is going to save? Either the electric circuit or the electrical appliances. And when it will save means whenever there is a underly high current flows. Underly in the sense whenever there is a excess amount of current is passing through the circuit or through the electrical appliances. So by the time the fuse will protect. And where we need to connect the fuse means always the fuse need to be connected only in a form of a series. Series means we already studied it's in a form of a end to end. That too, this fuse need to be connected only in front of the electric device. They will be asking the question whether we need to connect the fuse in front of the device or behind the device. Always a fuse must want to be connected only in front of the device. And then by using what are the materials we are going to make the fuse means copper, aluminium, lead. Sorry, copper, iron, lead. These are the major three materials what you are using in order to make the fuse. What are three major materials you are going to use? Copper, iron, lead. And then the range of fuse which is used in our domestic circuit is 1 ampere to 10 ampere. Even can just extend up to 15 amperes. So what are the range of fuse you are going to use in a domestic circuit? 1 ampere to 15 amperes you are going to use. Next, how the fuse works. So whenever more amount of current passes through the circuit, that means compared to the specified value, if more current is passing through that circuit means what will happen, that temperature of the fuse will start to get increased. The temperature of the fuse will start to get increased. Due to the increase in the temperature, what will happen means the thin wire which is present inside the fuse will start to melt, and once it reaches to a certain limit, it will break, and the circuit is considered as a broken circuit. And this is how it's going to protect or save the electric circuit, or it's going to protect the electrical appliances. That means whenever the excess amount of current is passing through the electric circuit means what will happen, the temperature of the fuse wire will get increased, and due to the increase in the temperature, the thin wire will start to melt and the fuse wire will break, and the circuit is considered as a broken circuit. So this is how the fuse is going to work in order to protect any electric device. Next, one of the important 2-mark questions, how to choose the range or how to calculate the range of fuse, what you need to use in order to protect any type of electric device. One of the important 2-mark question. So here we are having an example is an electric kettle. In order to protect this kettle, what is the range of fuse I need to use? Clear? In order to find this range, first we need to find how much amount of current is passing through this kettle. Clear? Now we need to find how much amount of current is going to pass through the kettle. So what is the power of the kettle they gave? 1 kilowatt. So P is equal to 1 kilowatt is given. So convert into watt. 1 kilowatt is nothing but called as 1000 watt. So what is the power is given over here? 1000, which is operated to a V is equal to 220 volt line. Calculate the range of fuse. That's what you are going to find. So in order to find that one, first let us calculate how much current is going to pass through the electric kettle. So the formula what you are going to use over here, it is P is equal to V into I. If I need I means how the formula will rearrange? I is equal to P by V. So I is equal to P. What is the value of power? 1000 by V. What is the value of V? 220. 1 0 0 we can cancel each other. Remaining what will be there? 100 divided by 22. That's going to be 4.545 ampere, or you can write it as I is equal to 4.55 ampere. That means what is the maximum allowable current through the kettle over here? The maximum allowable current through the kettle is 4.55 ampere. In order to protect this kettle, we need to use a fuse which is having a range of to the nearby value. What is the nearby value of 4.55? We can just use it as 5 ampere. So in order to protect the kettle, what is the range of fuse we are going to use over here? 5 ampere. Next, 100 joule of heat is produced in each second in 4 ohm resistance. Find the potential difference across the resistor. That means heat value they give. So what is the value of heat energy? H is equal to 100 joule. What is the meaning of the word each second? T is equal to 1 second, and R value they gave it as 4 ohm, and then they are asking us what is the potential difference. So what formula I can use over here means H is equal to V square by R into T. What formula are going to use over here? V square by R into T. So this formula we are going to use. Clear? So now what they are asking us to find? They are asking us to find the potential difference. If I need the potential difference, means how the formula will rearrange? V square is equal to H. Here R is in division, while coming to the other side multiplication. H into R by, here T is in multiplication, while coming to the other side division. So V square is equal to, what is the value of H? 100 into, and what is the value of R? 4 by, what is the value of T? 1. So V square is equal to 100 into 4, 400 by 1 is going to be 400. We need V alone, means take a square over here. V is equal to root of 400. V is equal to root of 400 is going to be 20 volt. What is the potential difference over here? V is equal to 20 volt. So the next question, why does the cord of an electric heater do not glow while the heating element does? Reason it is, cord. What is the meaning of the word cord? Means it's nothing but called as the wire. So if you are looking at an immersion water heater, we'll be using the wire over here, which is connected along with the plug points. Okay, so this one we'll be calling it as the heating element, and this one will be calling it as the cord. Cord means it's nothing but called as the wire. Generally, the wire what you are using over here, it will be made up of copper. That means it's a pure metal. Whereas the heating element, it is made up of alloy. Heating element is made up of alloy. Already we learned the resistivity of alloy will be high, whereas the resistivity of metal is going to be low. Clear? The resistivity of alloy is going to be high, whereas the resistivity of metal is going to be low. Since the resistivity of alloy is going to be high, the resistance also is going to be high. For which one? For the alloy. Whereas the resistance of metal is going to be low. Since the resistance is low, we all know the relation, heat energy is directly proportional to the resistance. If resistance is low, heat energy also will be low. So that is the reason the cord does not glow, whereas the heating element will glow. Next, compute the heat generated while transferring a 96,000 coulomb of charge in 1 hour through a potential difference of 50 volt. Compute the heat energy, that means H value we are going to find. Charge value they gave it as 96,000 coulomb. V value it is given as 50 volt. Based upon these three data already we gave a formula. What is the formula? H is equal to V into Q. H is equal to, what is the value of V? 96,000 into, what is the value of Q? 50. If you are multiplying these two numbers, we will be getting it as H is equal to 480, 48 lakhs joule. But this one we should not express in this order. We can write in a form of sub multiplication factor. Then I can write this one as H is equal to 4.8 megajoule. Or if I am going to express in kilojoule, means I can write it as H is equal to 4,800 kilojoule. 4,800 kilojoule. Next, an electric iron of resistance 20 ohm takes a current of 5 ampere. So what is the resistance of the iron? R is equal to 20 ohm and current I is equal to 5 ampere. Calculate the heat developed in 30 seconds. That means T is equal to 30 seconds. So here what is the formula we can use based upon the data? H is equal to I square R T. H is equal to, what is the value of I? 5. So the 5 the whole square into R value it is 20 into and T value is 30. H is equal to 5 squares are 25 into 20 into 30. Multiply these two numbers again. H is equal to 25 into 600. So that will be equal to, the final answer is going to be 15,000 joule. Final answer is going to be 15,000 joule. If I am going to express the same thing in a form of kilojoule, means I can write it as H is equal to 15 kilojoule. This one we can't express in a form of a megajoule. Suppose if you are going to express this one, means I can write it as H is equal to 0.015 megajoule. Next, two conducting wires of same material means the resistivity of both the wires are going to be same. Then I can write it as rho 1 is equal to rho 2 is equal to rho of equal length. The length of both the wires also is going to be same. L1 is equal to L2 is equal to L, and equal diameter D1 is equal to D2 is equal to D. If diameters are equal, then I can say that area of cross section also is going to be equal. A1 is equal to A2 is equal to A. First connect, if the condition is like this, means then the resistance of both the resistors also is going to be same. Then I can say that R1 is equal to R2 is equal to R. R1 is equal to R2 is equal to R. So now in the question what they are saying, first connected in series these two resistors. So what is series formula? R is equal to R1 plus R2. So R is equal to, what is the value of R1? R. R2? R. Therefore R is equal to R plus R, it is going to be 2R. Let's take this is equation number 1. And then in parallel, so what is parallel formula? 1 by Rp is equal to 1 by R1 plus 1 by R2. So 1 by Rp is equal to 1 by, what is the value of R1? R plus R2 also it is going to be R. So therefore 1 by Rp is equal to R, 1 plus 1 is going to be 2. Rp is equal to R by 2. Let's take this is equation number 2. Now come to the remaining part of the question. And then parallel across the same potential difference, that means potential difference also they said it is same. So there we can write it as V1 is equal to V2 is equal to V. The ratio of heat produced in series and parallel they are asking. So what does it mean by ratio? We are going to compare. Heat produced in series is to heat produced in parallel. So what is the formula we can use? I square R into T. This is for series. I square R into T, and this condition is for parallel. But they didn't give any data related to current, so you can rearrange the formula as V square by R into T. For series is to V square by R into T, and this is for parallel. So since we are comparing the ratio, potential difference, time you can calculate, as they said it is going to be same. But you should not cancel the resistance, because resistance in series is going to be 2R and resistance in parallel is going to be R by 2. So we should not cancel that one. Then how I can write this one? 1 by Rs is to 1 by Rp. 1 by Rs equal to, sir, 1 by Rs is to 1 by Rp. Now 1 by, what is the value of Rs? It is given in the first equation, 2R is to 1 by, what is the value of Rp? It is given in the second equation, R by 2. So Rs value it is given over here and Rp value it is in this place. Now one by 2R is 2. So rearrange into a form of normal. So I can write it as 2 by R. Then how I can write this one? That will be equal to 1 by 2R the whole divided by 2 by R. So 1 by 2R into R by 2. So 1 into R, R by 2 into 2R, 4R. So R will cancel each other. Remaining what will be there? 1 by 4 alone will be there. So either you can write it as heat produced in series is to heat produced in parallel will be equal to 1 is to 4. Next. So the next topic what we are having is about the electric power. In lower class we learnt about the term called as power. What is meant by power? Power is defined as the rate of work is done. But here we can't define in the same thing as it is, because if you are taking any electric device, it's not going to do any work, but it's going to consume the energy. Then how we can define the electric power? Means electric power is defined as the energy which is consumed by any type of an electric device in a unit time or per unit time. Generally we can define it as electric power is defined as the rate of energy consumed. Clear? And what is the formula to calculate electric power? Electric power is equal to energy consumed by time taken. Electric power is equal to energy consumed by time taken. And what's the formula to calculate power? It is P is equal to E by T. So remember this one also in a form of triangle, P, E, T. So the nearby means it's going to be multiplication, one above the other means it's going to be division. So power is equal to energy by time taken, energy is equal to power into time taken, time is equal to energy by power. Now, what is the unit of power? So the unit of power is watt. So the unit of power is watt, represented by the symbol W, which is named after the scientist James Watt. So what is the unit of power? The unit of power is watt, and the other unit of power is joule per second. How we obtain this one? So from the formula, P is equal to E by T. The unit of energy is joule. Unit of time is second. So you can write it as J by S. So how we can write this one? J S power minus 1. So what is the other unit of power? The other unit of power is joule per second. Joule per second. So what are the two units of power? The unit of power is watt and the other unit is joule per second. Joule per second. And what is the commercial unit of power? That means whenever you are going for a larger scale. Yeah. If it is smaller value means you can use it as watt itself. But if it is a larger value, so by that time we need to go along with the commercial unit, and the commercial unit of power is kilowatt. So read the question carefully. Either they are asking electric power or they are asking about the commercial unit of electric power. The unit of electric power is watt and the commercial unit of electric power is kilowatt, and 1 kilowatt will be equal to 1000 watt. 1 kilowatt will be equal to 1000 watt. That means 1 kW. kW means kilowatt will be equal to 1000 watt. Like that. If you are going to find for 1 watt means how I can rearrange? 1 watt is equal to 1 by 1000 kilowatt. 1 by 1000 kilowatt. And then how we are going to define this 1 watt? So 1 watt is defined as 1 joule of energy is going to consume. For example, if you are taking a bulb itself, in order to operate, that electric bulb is going to consume how much energy? 1 joule. In order to consume that 1 joule of energy, how much time it is going to take over there? 1 second. Then you can say that that bulb is going to have a power of 1 watt. So I will define 1 watt. 1 watt is defined as 1 joule of energy is consumed by an electric device, whatever the device it may be there. In order to consume that energy, how much time it is going to take? It's going to take a time of 1 second. Then how we can write this one? 1 watt is equal to 1 joule by 1 S. 1 watt is equal to 1 joule by 1 S. So the next one, it is a relationship between P, V, I and R. So P stands for power, V stands for potential difference, I stands for current and R stands for resistance. So what are three relations are there? P is equal to V into I. Second relation is P is equal to I square into R. and third relation is P is equal to V square by R. So what are three relations are there? P is equal to V into I, P is equal to I square into R, and P is equal to V square by R. So how we obtain these equations? So power is equal to energy consumed by time taken. Power is equal to energy consumed by time taken. So this energy we can also write it as work. Then you can write it as P is equal to W by T. So from the electric potential formula, V is equal to W by Q means, therefore W is equal to V into Q. So instead of W, we can write it as V into Q by T. So from the current formula, I is equal to Q by T. That means instead of this Q by T, we can rearrange it as I. Then what will be the final formula? P is equal to V into I. So now we obtain the first relation. That means a relationship between power, potential difference and current. So what is the relation? P is equal to V into I. And the second relation what we obtained, P is equal to I square into R. So how we obtain this one means, let's take this is equation number 1. So from first equation, what is the first equation? P is equal to V into I. Again, from Ohm's law. What is Ohm's law formula? V is equal to I into R. Now, in the place of V, we are going to substitute this IR. So, P is equal to I into R into I. I into Y, I square. So, P is equal to I square into R. P is equal to I square into R. Now, for the third relation, what is the third relation we are having? P is equal to V square by R. Again, we are going to obtain from the same first equation. So, what is the first equation? P is equal to V into I. But now, instead of I, we are going to substitute. How we are going to substitute means V is equal to I into R means I is equal to V by R. So, P is equal to V into V by R. V into V, V square by R. So, this is the third relation for the power. That means power, potential difference and resistance. Important relation. In maximum, in most of the cases, we will be using this formula. P is equal to V square by R. Don't forget that formula. Next, commercial unit of electrical energy. And what is the commercial unit of electrical energy is? Kilowatt hour. Clear? What is the commercial unit of electrical energy? Kilowatt hour. And 1 kilowatt hour is equal to 3.6 into 10 to the power of 6 joule. And 1 kilowatt hour is equal to 3.6 into 10 to the power of 6 joule. 1 kilowatt hour is equal to 3.6 into 10 to the power of 6 joule, or we can write this 10 to the power of 6 as. The reason the multiplication factor of mega is 10 to the power of 6. So instead of 10 to the power of 6, you can write it as megajoule. Remember this value. While conversion, we will be using this one. 1 kilowatt hour is equal to how much joule? 3.6 into 10 to the power of 6 joule. Next, a certain numericals are there. So read the question. An electric iron consumes the energy at a rate. Energy consumed at a rate means it's nothing but called as power. That means they gave the value of power. So P is equal to how much watt is given? 840 watt. When heating at a maximum rate, and P2 is equal to, when heating at a minimum rate is, it's going to be 360 watt. The voltage is, that means the potential difference is going to be 220 volt. So in the question what they are asking, what is going to be the current in both the cases as well as the resistance in both the cases. That means 1 as well as 2 we need to find, 1 and 2 we need to find. Clear? Now let's find the current in the case 1. So what is the formula I am going to use means P1 is equal to V into I1. If I need I1 means how the formula rearrange? I1 is equal to P1 by V. I1 is equal to, what is the value of P1? 840 by, what is the value of V? 220. If you are dividing these two numbers, 84 divided by 22, that's going to be 3.818 ampere, or I can write it as 3.82 ampere. So this is going to be the current in the maximum rate. Like that we will calculate for the current in the minimum rate. So P2 is equal to V into I2. So I2 is equal to P2 by V. I2 is equal to, what is the value of P2? 360 by 220. So 360 divided by 220, it's going to be 1.636 ampere, or we can write it as 1.64 ampere. Now we'll calculate the resistance. So resistance you can easily calculate by using the Ohm's law formula. R1 is equal to V by I1. V is going to be 220, and what is the value of I1? We calculated 3.82. Now divide these two numbers. 220 divided by 3.82, that will be equal to 57.591 ohm, or 57.59 ohm. Now we will calculate for the second case. R2 is equal to V by I2. V is going to be 220 and I2 is going to be 1.64. So 220 divided by 1.64, that will be equal to 134.146 ohm, or we can write it as 134.15 ohm. Next, an electric bulb is connected to a 220 volt generator. That means the potential difference of the generator is going to be 220 volt. The current through the bulb is, some change alone is in, it's not 0.05, it's 0.5 ampere. The current through the bulb is 0.5 ampere. The power of the bulb we need to find. So what is the formula based upon these three data? You can use P is equal to V into I. So P is equal to, what is the value of V? 220 into, what is the value of I? 0.5. So P is equal to 110 watt. So what is the value of power over here? P is equal to 110 watt. Next question. Related to the commercial unit of electrical energy. So read the question. An electric refrigerator rated, it's not rater, it's rated 400 watt. That means the power of the electric refrigerator is given in a form of a smaller unit. That means 400 watt, that means in normal unit they give. So this 400 watt we need to convert into a commercial unit. In order to convert into a commercial, what we are going to do means we are going to divide by using 1000. If you are dividing the two numbers, it will become as 0.4 kilowatt. That means what is the power of the refrigerator over here? P is equal to 0.4 watt kilowatt. Now for how much hour it is working? 8 hour it is working. It's working for a time of T is equal to 8 hour. Next up, what is the cost they are asking for 30 days? Clear? For 30 days we need to find, and if they are charging for each unit is rupees 3 per kilowatt hour. Clear? So this is what you are going to find. Now first we'll calculate the energy which is consumed by the refrigerator for 1 day. So what is the formula to calculate energy consumed? Energy consumed is equal to power into time. Energy consumed is equal to power into time. So the energy consumed for 1 day is going to be, what is the value of power over here? 0.4 into, for how much hour it is working? It is working for a time of 8 hours. 0.4 into 8 is going to be 3.2 kilowatt hour. Clear? This is the energy which is consumed by the refrigerator for 1 day. Next we need to find for the 30 days. So energy consumed by the refrigerator in 30 days is going to be energy consumed by the refrigerator in 1 day into 30. What is the energy consumed by the refrigerator in 1 day? 3.2 into 30. If you are multiplying these two numbers, you will be getting it as 96 kilowatt hour. Now what is the overall energy which is consumed by the refrigerator for all the 30 days? Is going to be 96 kilowatt hour. Now we will calculate the cost. In order to calculate the cost, we are going to use the formula energy consumed by the refrigerator, that means the total energy into cost per unit. What is the energy consumed by the refrigerator in 30 days? 96. And for each unit, how much rupees they are charging? 3 rupees. Therefore, cost will be equal to 288 rupees we need to pay for the refrigerator for the 30 days if it's working for 8 hours per day. Next, what determines the rate at which the energy is delivered? Rate at which the energy is delivered is nothing but called as power. So what is the answer? Answer is nothing but called as the power. Reason, we all know power is defined as the rate of energy consumed. That means rate at which energy delivered means it's nothing but called as power. Next, an electric motor takes 5 ampere from a 220 volt line. That means I is equal to 5 ampere. What is the potential difference over here? V is equal to 220 volt. Determine the power of the motor as well as the energy consumed by the motor at a time of t is equal to 2 hours they are asking. First, let's calculate the power. So P is equal to V into I. What is the value of V? 220 into I. What is the value of I? 5. 220 into 5, 1100 watt. What is the value of power over here? P is equal to 1100 watt. So this 1100 we need to convert into the commercial unit. In order to convert into a commercial unit, we are going to divide the given number by using 1000. 1100 by 1000 it is going to be 1.1 kilowatt. So why we convert like this means because they are asking for the energy consumed, commercial unit of energy. Energy is equal to power into time. So the energy is equal to, what is the value of power? 1.1. And what's the value of time over here? 2. 1.1 into 2 it is going to be 2.2 kilowatt hour. Next, which of the following term does not represent the electric power? That means there are 4 options are in. A is equal to I square into R. B is equal to I R square. C it is V I. And D option is V square by R. In this they are asking which of the following term does not represent the electric power. So if you are saying over here, this one is the formula, V into I is the formula, V square by R is the formula. Which one is not the option? P is equal to IR square is not the option. That means what is the option over here? Option B. Next, an electric bulb is rated. That means power of the electric bulb is 100 watt, which is connected to a potential difference of V is equal to 220 volt. And when it is operated on 110 volt. By that time they are asking what is the power. So if potential difference is changing also, the resistance of the bulb it won't change. So first by using these two data, let's calculate the resistance. So what is the formula we are going to use over here? P1 is equal to V square by R. So from this relation you are going to find. Clear? So what is the relation? P is equal to V square by R. So now if I need R means how the formula will rearrange? R is equal to V square by P1. R is equal to, what is the value of V1 over here? 220. V square means 220 into 220 by, what is the value of power it is given? 100. 0, 0, you can cancel each other. Then R will be equal to 22 into 22, 484 ohm. Now, the resistance of the bulb we found. What is the resistance of the bulb we calculated? 484 ohm. Now, by using this value, we can calculate the power. So, P2 is equal to V2 square by R. P2 is equal to, what is the value of V2 here? 110. Then we can write it as 110 into 110 by 484. Now multiply 11 into 11, 11 into 11 we all know it's going to be 121, double zeros again, added last, divided by 484. If you are dividing these two numbers, 12100, that means 12,100 divided by 484, it's going to be 25. That means the power of the bulb in the second case is going to be 25 watt. 25 watt. So while writing the units, write it carefully, don't make any mistake in the unit part. Next, several electric bulbs are designed to be used on a 220 volt line. That means the potential difference V is equal to 220 volt electric supply line. Rated, that means the power of each bulb they said it is 10 watt. How many lamps? That means number of lamp we need to find. So you can go along with the formula. N is equal to I into R by V. Clear? Can be connected in parallel across each other across the two wires of a 220 volt line if the maximum allowable current is, that means through this circuit how much current is going to pass? 5 ampere. That means N I am going to find, means I can use the formula N is equal to I into R by V. But in the question I don't have R. So how I am going to find the R means by using the formula P is equal to V square by R. If I need R means the formula will rearrange it as R is equal to V square by P. What is the value of V? 220. Then you can write it as 220 into 220 by, what is the value of power? 10. 1 0 0 we can cancel each other. The resistance of each bulb is going to be 22 into 22, 484. 1 0 is in, add at last. That means what is the resistance of each bulb? Each bulb is going to have a resistance of 4840 ohm. Now use this formula in order to calculate the number of bulbs. So N is equal to I into R by V. What is the value of I? I it is going to be 5 ampere. And what is the value of R we calculated? 4840 by, what is the value of V? 220. So multiply the numerator part. So what is the numerator? 5 into 4840. It's going to be 24200. That means 24,200 by 220. Now divide these two numbers. 24,200 divided by 220, that will be equal to 110. That means how many bulbs you are going to connect over here? 110 bulbs. One of the important question in model exam they will be asking this one. Next, Compare the power used in a 2 ohm resistor in each of the following circuit: a 6 volt battery in series with a 1 ohm and 2 ohm resistors, and a 4 volt battery in parallel with a 2 ohm and 12 ohm and a 2 ohm resistor. So there are two circuits at the end. The one circuit is in a form of series. Series means we all know it's in a form of a end to end. So what are two resistors at the end? 1 ohm, 2 ohm, which is connected along with the battery, which is having a potential difference of V is equal to how much volt is given? 6 volt. And another one circuit is there, but it is in a form of what type of combination? It's in a form of a parallel combination. Parallel means we all know it's in a form of a common point, yeah, which is connected to a battery of potential difference V is equal to 4 volt. And then what is the resistance value they gave? 12 ohm and 2 ohm. In the question clearly they are asking compare the power in the 2 ohm resistor alone they are asking. That means we are going to calculate the power in the specific resistor only we are going to calculate. Clear? So look at the first circuit. Is it series or parallel? It's in a form of a series combination. First we need to find how much amount of current is passing through this circuit. In order to find the current, we can use the formula R is equal to R1 plus R2. What is the value of R1? 1 plus 2. 1 plus 2 is going to be 3 ohm. Now find the current. I is equal to V by R. What is the value of V? 6 by. What is the value of R? 3. 6 by 3 is going to be 2 ampere. How much current is passing in this circuit? 2 ampere is passing. Now we can calculate the power in the first circuit. In order to calculate the current, P is equal to I square into R. We are going to use the formula P is equal to I square into R. P is equal to, what is the value of I we calculated? 2. So 2 the whole square into R means what is the value of R? 2 ohm alone we need to consider. 2 the whole square, 4. 4 into 2, 8 watt. This is the power of the bulb in the resistor in the first case. The second case let's calculate. In parallel the amount of current is going to vary. Then directly you can use the formula V square by R. Why? Because in parallel the potential difference is going to remain the same. So P is equal to, what is the value of V? 4. Then 4 into 4 by 2. 1, 2. 4 2s are 8 watt. This is the power in the first case and this is the power in the second case. So they are asking us to compare. Compare means we all know it's nothing but called as the ratio. Now take the ratio for P1 is to P2 alone. So P1 is to P2 will be equal to 8 is to 8, or we can write it as 1 is to 1. So two lamps, one rated 100 watt at 220 volt line and the other rated 60 watt at a 220 volt line are connected in parallel. Means P1 is equal to P2 is equal to 60 watt, V is equal to 220 volt. It asks us to calculate the current. So first what we are going to do means we are going to calculate the net power. So how we are going to find? P is equal to P1 plus P2. P is equal to, what is the value of P1? 100 plus 60, 160 watt. So now P is equal to V into I is equal to P by V. So I is equal to, what is the value of power, net power? 160 by V value is going to be 220. If you are dividing these two numbers, 160 divided by 220 I is equal to 0.727 ampere, or we can write it as I is equal to 0.73 ampere.